Good morning, ladies and gentlemen, esteemed guests, and conference participants. Welcome to VIPER. I'm Sahitya, your host for today. We gathered here to exchange ideas and open discussions on an interactive workshop on research and clinical trial protocol design, statistical analysis, and publication, a transformative journey. It is indeed a golden opportunity for each of us to enrich and enlighten ourselves. As you know, a conference is not just a place for listening to speakers, it's a space for learning, exchanging ideas, and coming together as one to explore the topics that matter the most. We are about to commence our event by lamplighting ceremony, the knowledge of wisdom. This is a symbolic moment that signifies the dispelling of darkness and igniting of thought and enlightenment. Shubham Karoti Kalyanam, Arogyam Dana Sampada. Kshetrabuddhi Vinashaya, Deepam Jyoti Namostate. I request dignitaries on the dais to light the lamp and symbolically inaugurate the program. Dr. Rajshekar P., HOD, Associate Professor in the Department of Pharmacology.
So, good morning. Just I'm here to brief what exactly happened behind the screen. So, as we know, this is a two-day interactive workshop which entitles Research and Clinical Trial Protocol Design, Statistical Analysis and Publication, a Transformative Journey. So, it's a 2 days workshop. As you know, it's going through hybrid mode through YouTube streaming also. So there were around 190 registrations, paid registrations throughout the country. So there was a tremendous effect by the registration committee team to put forward their own strength so to make it possible. So I would like to appreciate all those who have registered for the workshop. And as you know, if you go to the glimpses of all the lectures, as we know, we are fortunate to have this should be an offline actually, USFDA expertise will be sharing their knowledge. So moreover, the if you go through these 2 days sessions, both the sessions, both forenoon and afternoon in 2 days, definitely you will be an expertise to to come out as an Q1 journal publication, which is uh, the most important, I believe. That was the whole thing is to articulate you how artificial intelligence will help you in review of literature to frame your objectives and methodologies, and how you can uh, pipeline your publication so that it can be eligible to publish with valid data into Q1 journals. That is the whole idea. So I would like to thank Dr. Jagdish, who is an instrumental person to make it happen, because he's the one who is associated with us. Thank you, sir. So, with all your experience, almost 40 years of experience in US FDA and expertise, he could able to bridge the gap actually. He is the one who has connected with Balakumar and Dr. Subodha. Anyhow, Dr. Srinivas Raju sir is a very good friend of our principal sir. So we would like to, the world is small, we can say the dots are connected very closer. So what I mean to say is, the bottom line is, so I want you all to take the best outcome. Uh, Most of you doesn't know the value of thing exactly, but I would like to, at this juncture, I would like to make a note. Try to utilize this session. Definitely, they are going to useful. The expertise, the resource persons were highly qualified. So if you go to the profile that, so I would like to urge, thanks to Principal Sir, who is we want to do this with a lot of efforts behind it. I would like to thank Dr. Srinivas Raju sir also. He has for his time to visit all the way beyond. He got his flight today's night. He's flying to US back. Thank you, sir, for your time, and we look forward to learn from you through all the sessions. So again, once again, I want to thank all the participants who are joined online. Thank you. Only one thing I want to share is we definitely keep up your expectations. Definitely, whatever intentions to join for the workshop will be fulfilled. Hope. Thank you and all the best. Thank you.
Thank you, sir. Dr. A. Ramesh, Principal, VIPER, have 26 years of teaching experience. Thank you.
Good morning. Respected chief guest of today's function, Dr. Jagdish, my good friend and classmate, Dr. Srinivas Raju, my colleague, Dr. Rajendra Prasad, of the dais, the organizing committee, and my colleagues, and most importantly, the delegates who are attending online who have come here. I think it's a wonderful culmination of all the things within short span of time. I'm very glad to have the distinguished scientists here, ministers, and I'm happy to have Dr. Fred, who is an wonderful scientist and a very famous physician there, to be a part of this program. And we also have Dr. Balkumar. We also have a very good librarian among our team. And tomorrow afternoon, we also have the CEO of the hub being a part of this program. So I think we all are very fortunate to have such an important resource persons to be a part of this program. Thank you all. And I think you should be taking Dr. Jagdish as a role model. You'll be sorry to say on the online mode. Can you assess his age? 50, 60. Okay. So let him reveal it. Okay. Anyway, so I'm happy that the energy he has, I think all of us will not be even having one fourth of it. So I think the one important thing we should learn from you is the passion to do something beyond, right? He keeps on tapping us. He keeps on sending mails to us. He keeps on sharing the information which is going across the world. And that's how they differ from person to person. So, what I want to tell you is that a person with such a passion is happy to interact with us. We already had a earlier series one in our Vedic last year, and that was a super hit. And I think I'm happy to share that we had a publication of those conference. So just imagine a conference was made into a publication, which I think I never thought, right? And that was published, and that's the capacity of these people. So I definitely can share that this can take us to the next level, provided you all have that same passion to learn. And I'm happy to have Dr. Raju, who is the scientist right from our days. So he's always passionate to do something more. When we all used to enjoy, he used to do some experiments which are different from the rest of the crowd. So I'm happy that he's also here. So with all these people as a team, I think we all are fortunate to have them. Thank you all. And I think in the interest of time, I'll be happy to share our feedback at the valedictory. Thank you once again.
Dr. Jagadish's illustrations career span over 5 decades, marked by his significant contributions to the field of pharmacy, pharmacology, toxicology, pharmacokinetics, and medical sciences. His journey began as a research fellow, progressing through academic ranks to become a distinguished professor at academic institutions and culminating his role as a senior expert pharmacologist at the US Food and Drug Administration for nearly 33 years. Dr. Jagadish holds a bachelor degree in pharmacy from the Government College of Pharmacy, Bangalore University, a master's degree from All India Institute of Medical Sciences, New Delhi, and a doctorate in pharmacology from Banaras Hindu University, Varanasi. He was Canadian Heart Foundation Fellow at the University of Saskatchewan, Canada. He taught pharmacology at BHU Varanasi and Northeastern University College of Pharmacy, Boston, USA. Currently, he is distinguished visiting professor at various colleges in Karnataka. His supervision in numerous graduate and doctoral this underscores his commitment to mentoring the next generation of scientists. His specialized knowledge in cardiovascular and autonomic receptor pharmacology, as well G protein coupled receptors, and been pivotal in role of FDA, where he meticulously reviewed preclinical studies to ensure drug safety. His profound knowledge and extensive experience have been instrumental in the research and development of drug products. I request Dr. Jagadish to share his valuable insights. I request Dr. Rajendra Prasad sir to provide word of thanks. Sir, we request your valuable insights. Thank you. No, sir, please let me do this. Dr. Srinivas Raju Datla is currently working as postdoctoral fellow at Cardiology Division of Emory University, Atlanta, USA since 2008. In 1999, he was appointed as pharmacologist at the Dr. Reddy's Research Foundation, Hyderabad, India. In 2003, he was appointed as Sir Research Scientist at the Ransbeg University Laboratories, Delhi, India. Dr. Srinivas Raju Datla received his B Pharmacy in 1995 at Gulbarga University, India. He got M Pharm in Pharmacology in 1999 from Andhra University, India. Dr. Srinivas Raju Datla obtained PhD from Melbourne University, Australia in 2008 in cardiovascular pharmacology. Dr. Srinivas Raju Datla currently researches interests are cardiovascular pharmacology, drug discovery, NADPH oxidase, oxidative stress, pharmacology. I request Dr. Srinivas Raju Datla to provide his valuable insights.
Good morning, everybody. So I think this is my third time coming here in the last 2-3 years. So I happen to see the energy, and also I'm from almost similar place like Hyderabad. I worked in Dr. Reddy's and then moved to Ranbaxy. So, but I was here in Dr. Reddy's for almost 5 years, and virtually and Bolaram formulations for another 2 years around. So all this knowledge gained in the industry in combination with my M Pharmacy and B Pharmacy education really helped me to build my career. So that's how I happened to come back and talk with students, more of like a general discussion. That's how me and Ramesh had a good interaction. But in like FDA, when Dr. Jagadish was retiring, we had a good chat, and then I realized his interest in educating the students here, like to improve the research skills, which are like need little bit boost to reach the global level. So that happened to be a good talk. Like then I immediately thought of Vishnu College of Pharmacy because of my interaction with Ramesh. So last year, I think we had like Dr. Jagadish had one two days workshop, and this is another round. So I happened to talk with him like a few days back, maybe a couple of weeks back, that I'm going to India. So he quickly fixed a time. I actually today is my flight, so I was pulled to be part of this. But I'm really happy that I'm sharing some of his goals today to give a break from his. This is again like to improve the research quality of the academic institutions. So I'm very happy, and thank you, Dr. Jagdish, for associating with Vishnu College of Pharmacy. I don't have any personal interaction, but like always see you guys to get some benefit out of it, to get to the like current trends or like the ways like that you need to improve your research skills. Like that is how you learn, and also ready for the industry and build your career. And thank you very much.
Thank you so much, sir. As we draw towards enriching the event, it's time to express our gratitude to all those who have contributed to this success. To deliver the vote of thanks, I would like to invite Rajendra Prasad, sir, Vice Principal VIPER, onto the dais.
Thank you. Very good morning. Uh, it's my pleasure to propose vote of thanks on behalf of Vishnu Institute of Pharmaceutical Education Research during today's event, today's workshop on some innovative approaches in designing clinical protocols. And I would like to extend our heartfelt thanks to Professor Jagadish, the senior scientist and pharmacologist, formerly worked at the US FDA. Thank you, sir. Thank you very much. for sharing you're going to share the valuable insights. I would like to thank Professor Srinivas Raju. Thank you, sir. Thank you very much for accepting our invitation and spending the time, valuable time with us. And I would like to thank our respected principal, Dr. A. Ramesh, for everything, for making this event happen. And the organizing secretary, Dr. Rashekar, and your team, and all the participants, around 200 participants. I hope we'll have a fruitful, innovative discussions and lecture discussions next two couple of days, next 2 days. And once again, I would like to thank all the resource person, especially Professor Fred and Balakumar, for accepting and having the interaction with the students during this today's workshop. Thank you, and thank you very much. Good day.
Thank you so much, sir. I request the dignitaries to occupy the seats of the dais. Volunteers, please help the management to clear the dais. I request the volunteers to clear the dais. The development of well-crafted research questions and hypothesis-driven research protocols is a crucial aspect of scientific inquiry, requiring a unique blend of creativity, critical thinking, and methodological rigor to cultivate skills in developing research questions and hypothesis-driven research protocols. Researchers can enhance the validity, reliability, and overall quality of their research, ultimately contributing to the advancement of scientific knowledge and understanding. I request Dr. Jagadish sir to occupy the dais. Over to you, sir.
Very good morning to everyone. Astronomy, scientific alignment, class alignment, space is able to align all the planets possibly here to deliver a lecture, series of lectures, a different kind of people who are very experts in this area. So, has got three FDA people, myself and Dr. Raju, we are here. Tomorrow, Dr. Fred Senator will be joining this workshop. Of course, you might have seen that book. It is in the library which I gave last time, and he associated with us in editing that book. So you will be having people from three people from FDA. Of course, I'm ex. So before last year, I retired, and Raju is joined actually during COVID time. Just before COVID time, he joined, and now he's continued to be in the same division where I was working earlier for 33 years. I'm glad he's associating with me in this workshop, and I would like to take his knowledge further into this area. besides our regulatory process in that FDA. So he will be very much deeply involved in teaching the young graduates and postgraduates and the research aspects, because we are very much interested in the fundamental aspects of research, not going very much into advanced other things which you will be learning in due course of time. Definitely a lot of people coming and giving lectures on variety of topics, advanced topics they will be giving, including like CRISPR, they will be giving talk on those things, but not about the basic aspects, fundamental aspects like principles of drug action, which is so tough to understand. Such things we must able to focus on those things. That builds your foundation for further education. So we should learn the basics, ABC of research. This is what I've been focusing for the past 20 years in various colleges in India, from you can say from Tamil Nadu, Kerala to the top north Punjab state. I went not to Kashmir, but up to Amritsar. So our main goal is to teach them the basics. That is, what is research? How do you write protocols? And how do you analyze your data? And then how do you publish in quality journals without compromising the ethics part, both bench as well as the publication part? So these things, fundamental things, are very much required, which many of us lack knowledge in this area. For last 15, even worldwide also, that nothing was existing in 70s or 80s when we were students. Of course, I belong to the generation of 70s, which none of you people are born. So I graduated in 1970, and at that time, there was no such methodological way of teaching. We used to learn from our supervisors how to write protocol, or how to, it was restricted to the laboratory. Each laboratory was different. The way they used to learn from the supervisors, they used to learn on their own. So self-made people. So like this, I am also self-made. So we built up on our own. Now, for last 15, 20 years, of course, I written 2 books, which last time I showed you, one green book, the biomedical research book published in 2009, 2010. Other one was last year. That is on the fundamental aspects of basic research. Of course, this time I added extensive on clinical research. So for those who are very much involved in the clinical research, I know pharmacy practice people and also Form D people are involved in the clinical research. I went through their syllabus. So accordingly, that's why I thought we should have a couple of talks on this area. So tomorrow will be oriented towards that line, starting from the clinical design to that of, of course, we should have also get some talks on pharmacovigilance and pharmacoepidemiology. That also would have been a nice one. You can add up the next time pharmacovigilance, which is also a part of syllabus in Form D and pharmacy practice courses, which all of us should know about those things. We also got topics in our book. So, and coming to this line of thinking, the basic aspects of research. So today's talk, the first two we'll be discussing about the writing protocol. During the writing protocol, you come across lot of things. That is, what is my topic of research? How do I get into the right topic so that I should be able to complete my research in the given duration of time? Like for example, 9 months to 10 months for M forms, and PhD, of course, 3+ years will be there. So you'll be debating, taking the right one rather than fishing around, wasting a lot of time. Of course, it's not a wasting of time. Experience is a good school, but its fees is very heavy. That means you learn a lot, but only think at the cost of spending like many years. This is what I did it, and I spent many years, learned a lot of things, but only thing is it costed me many years, but picked up a lot of techniques, a lot of knowledge. It improves your knowledge, no doubt. And in this process, we will be giving a lot of stream of lines that is starting from the topic to that of rating or experimental methodology. During that process, you come across variety of things, including the dose selection, which is the next topic. Dr. Raju will be discussing about what kind of dose you're looking for it, whether from the therapeutic to the toxic dose. How do you select the right dose for your experiments? Not to gamble with time and money. And because money means you are spending a lot of money on the animals, you are wasting a lot of animals. So that should not be compromised. That part we'll be talking in the second one. Here I'll introduce all the steps, and then plugin will be there in the various talks. So this lays the foundation, because as I said, developing research questions followed by hypothesis. So with research questions based upon the topic of research. So first you should have a topic. From the topic you will get into research questions, then to hypothesis. If you know all these three steps, then you will be able to write your protocols, which is based upon your creativity and variety of thinking paradigms. That is creativity, critical thinking, and creative thinking. Those things are merged together, so you'll be able to develop into a very nice topic, and the topic will be divided into several ways of expressing. So that builds up your, once a good protocol being set up, you will know, you will be having a very good confidence that yes, I'm doing correct way of proceeding with it. So you should not stumble in the beginning itself. This is what we are going to learn from the subsequent of my talk. That is outline of my talk. As you seen this one, after introducing, I'll put into 4 cornerstones and 5 elements, Panchabhuta. So that means how all of them are assembled together, which get into a right topic and right protocol writing. The topic of research based upon your ideas and variety of thinking process, get into a right topic. From that topic, you will get into research questions, will get into hypothesis, then you will have a aims or aim. Single aim will be there usually, but in case of PhD thesis, you will be having a couple of aims, but many objectives will be there for a research project. Then why do you want to carry out the research? What is the significance? What benefits are there? So to the scientific society as well as to your institution or to the country. So that part we'll discuss and summarize the whole thing. Introducing this one, writing a proposal or a protocol, anything putting in the paper is very tough job. It is not easy. By phone call, you can always do it, or chatting, you can do with abbreviations, telegraphic codes. But however, writing a protocol which can pass through the reviewers, gatekeepers, so it is a very tough task. For that, you require a lot of thinking process. The proposal story must be unforgettable that the study circle members can follow it and secure it. Study members here are reviewers, not only from your guide, but also when you go to the university, people, the study board should be able to say that, yes, the protocol is acceptable. So then only you can start your work. Every research proposal starts with an innovative idea. Without ideas, you cannot start your work. So a particular should be, they should think in a process. For example, starting this workshop, we had a lot of ideas. Lot of correspondence took place between me and your institution to get into the right topic. Several hours and days we spent in getting a right thing. So idea is very important doing this one. From the idea, you get into a correct topic, research topic. Once topic is there, research questions, then hypothesis, aims and objectives one, and benefits. So I summarize all these things in this paragraph. Now you know the definition of research. I don't have to fill this one. Only thing, one point I have to stress is here, the research is mainly to fill the potential knowledge gaps. That means what has not been done, niche. So that is first year ideas, which again I'll be talking about this thing, that what kind of ideas first year and second year are copycat research. That is not allowed. So that means you have to focus on an original research idea. So it means you are filling that gap which is existing in the literature, that you have to harness that gap to understand the concept in one facet, a major subject specialization. In the M.Pharm level, you go for one subject, but when you keep on proceeding subtopics, that means super specialization, emerging field will catch up. Just like I'm in the cardiovascular pharmacology. Again, cardiovascular pharmacology, I'm interested in the cardiac or the vascular side. Again, I'm in the hypertension area. Again, hypertension area, I may think about it. What are the different factors that causes hypertension? So I may focus on renin-angiotensin part. So in that way, you focus emerging field, and super specialization takes place. So at the M.Pharm level, you go for a subject specialization in some single subject you take. Later on, you can get into a branches, and then you master in, and you will have a, so that you can write a grant on any particular topic. You cannot write on a wide topic, a narrow, small topic, pick up and then do research. Research includes the generation of multitude ideas and scientific insight and also societal needs. You scientists can develop new theories, ideas, produce products that shapes our society and everyday life. So this is what I've given introduction that why we carry out the research work. Research is a theoretical and empirical part. What we discussed today is a theoretical part because the starting point of scientific research is to conceptualize a research topic. This is done by reviewing and analyzing existing literature, a good review of literature, which helps crystallize ideas. Subsequently, hypotheses and objectives are formulated based on this process. So today we'll be discussing this part only. Empirical, you carry out. So once theory is set up properly, then you carry out the experimental part. So theory follows the empirical studies in the laboratory. This one, as you see, follow this flow diagram. Research statement, a particular statement is given by your supervisor or a guide, and you will be mulling over that particular point, how I proceed further one. You gather a lot of ideas from your mentor, from your colleagues and other things. With applying creativity, creative thinking, imagination, and reviewing through literature, you get some ideas and discuss with your supervisor and evaluate a right topic for your research. Develop research question, hypothesis, right objectives one, coming to rationale behind the studies, significance. So this part you write everything. Once it is everything is done, based upon the objectives one, you write the methods, experimental design, which I'm not discussing this one. This is a separate topic itself, which we held with our AAGCPA. Our association is there in America, American Association of Government College of Pharmacy. There we conducted a webinar on this experimental design. Then how you group number of groups, number of animals for each group. So that is a very good part to design. That you will write down this one methods. Then you start your laboratory studies or a clinical studies oriented, like if somebody is doing an ADME, PK studies, clinical pharmacology, do this one. Then once you get your data, you tabulate, analyze, and then you go for publication or thesis. When you say publication, Dr. Ramesh was explaining that, saying that the whole workshop has been turned out into publication. Same thing, whatever we're discussing here, some of you may take a lead and write a paper on this one, collaborating with your supervisor or some 2-3 teachers or 2-3 colleagues, can get this one and then publish in one of the journals. So you can also do it. You can take a model papers, which I can send you people, a couple of papers we publish, and variety of workshops and symposium and proceedings one. So you can also write a paper on today's workshop. You can always say that today's workshop was held in this one. This is a topic discussed. You can write a summary of each topic, what we discussed, which speaker spoke on this one aspect. You can build about 5 to 6 pages, printed pages of the summary of this workshop. Think about in your idea now itself that whether you can write a paper on this one, which we published also on previous ones, which I will be able to give the copies to you. Now see, I divided into 2 parts. This is a theoretical part, which is on your paper as a protocol, and this is your laboratory part. Now, before you begin research, you must consider 3 critical elements. One is the plan of study, that is the protocol which you should write, and you must have a guide, a mentor, and infrastructure, environment, that is a good building, a good number of equipments to do this one, a good library setup. So, and also people with whom we can discuss. Environment makes a lot of difference. So if a good laboratory, good surroundings, good library means it is more or less 50% of problem is solved, because you will be able to get a good amount of information which is needed for your work. So infrastructure. So these 3 are essential to carry out your studies. A protocol, what is protocol definition? For example, protocol is whether an experimental or clinical is a roadmap for research that evolves from the basic outline of the study plan to eventually become a competent research or grant proposal or a thesis. So that is the basis for writing either proposal or for a protocol. It provides the structural support for the research in the form of a thesis, dissertation, or publication. This is the structured outline of thesis itself. Only thing it lacks results and discussion, summary and conclusion, because you have not done the experiment. So you have just outlined everything needed for the proceeding work. So that becomes a basis for writing thesis also later on. So once you're done, very good job here in putting the protocol properly. So this is how you proceed to the end. So why do we need a protocol? It is the first step in successful research undertaking. It helps the candidate organize the research in a logical, focused, and efficient way. It also gets the feedback from your supervisor. So when you write all the things, you can keep on showing, and every time you can see, give to your colleagues also. Can you comment on my protocol? So somebody may say, oh, Samir, you have made mistake here and there. So that also gets a very good feedback. So that's why you register all these things. And it's the written reminder that what has not been done, what has to be done. So that way you'll be able to brush up your knowledge. Guidelines for writing protocol differs from department to universities. So what I was telling you, 1970s, when I was a student at All India Institute of Medical Sciences, the way we used to write protocol was different from the another professor. So there was no proper guidelines. Even though small guidelines was given by the registrar's office, how to submit a protocol, but still it is to differ, and from lab to lab, even the university to university may differ. But I will be giving a very overall structured outline, which you may modify also later on, but those basic elements are needed, are given now. See the scheme runs here. The researcher write a study outline, a page based upon the discussion with their guide, and then makes a draft protocol where a lot of people will be putting input here, statisticians, literature review, all those things. Your protocol will be draft process, and then it will become a final protocol after getting a lot of revisions, doing a lot of revisions and getting input from your guide, and then protocol be ready for submission to the university for approval. Then you start your work. See, nothing but the anatomy of research. The basic skeletal structures are being developed before you proceeding to the next step. Then you start performing the experiments, collecting the data, analyzing and interpretation, then goes for thesis. There is nothing but a empirical part, that is the physiology of research. Once the anatomy skeleton is there, you put the muscle and everything here. Now, elements of the research protocol. What are the different elements? One is the research topic, which is the basic. Without research topic, you cannot proceed anything. It's based upon your novel idea derived from the background information, review of literature, past 10 years. I've gone through about hundreds of protocols. Students always do not quote the recent past 1 or 2 years reference. So they always quote something 1995, 1903, 2003, 2005. No, you must show that you are referred until the last a couple of months ago published papers, or at least 1 year, the last year publication, so that to show that you have a current knowledge, that work has not been done by others, that has to be demonstrated in your writing. Otherwise, if you don't quote 2000, for example, now it is 2024 ending, 2023 paper should be there, some citation should be there. That gives a reflection that yes, the candidate has gone through that particular paper, and that means understood that what is the current knowledge on that particular topic, that reflects. So it's very important, and that's why you will be able to identify the gaps, that is the niche. So that gives an overall picture that the student has gone through the past 10 years literature, including the last 1 year publication. Then the research questions developed from this topic, hypothesis, which should be under aims and objectives, significance and innovation benefits, derivatives. This is the way how these are the four or corners: topic, question, hypothesis, objective, four corners. If I add a significance, which almost all universities will be asking for, that's why I made this as a 5 elements. Other 4 is a must. Significance, even in grant proposal, there is a column NIH or your local ICMR, DST, ACT, they ask for what is the significance of your research. Why you want to, why should we give you 10 lakh rupees or 50 lakh rupees for you on this project? Is there any benefit for the society, for our country or anything else? You must say that what benefits are accrued. So I'll be giving a lot of examples in all these cases to illustrate these points. Then finally, experimental design, and which also include meta-method, subjects, variables, statistics, everything. So all this constitutes in your protocol. So I will take one by one, 1, 2, 3, 4, 5, go like this way. The research topic is the keystone of the entire scientific enterprise. It begins the project, drives the entire study, and is crucial in moving the project forward. It dictates the remaining elements of the study, and those should not be too narrow or too broad or unfocused. And because of this potential, it was essential that a good novel scientific idea based upon the review of literature should be every time of stress about review of literature. This is what next Dr. Balkumar, the third lecture, will be talking about review of literature. How you get into the review of literature, that is very essential to get an idea and to coin a research topic. So idea detection flashes, if you're an experienced researcher, that's why always the supervisor gives the research topic to students, because students are not well versed with first year inform, they will not be having that much knowledge about topic. That's why they depend upon the teacher. That's why they always idea flashes as researcher. They plug in the student to a particular topic and then develops the whole topic protocol. Or you should be a voracious reader of scientific articles, which Dr. Ramesh was telling that I keep sending research digest every month, collecting from various one. You should always not only focus only on your topic, variety of topic you should read. Oh, I'm a cardiovascular, I should not read anything about CNS or anything about chemotherapy. No, not like that way. You should have a wide knowledge, like a broad spectrum antibiotic. Should have a lot of knowledge about various aspects, and only can able to coordinate them. There is no watertight compartment between chemistry or pharmacology or pharmaceutics. Recently, that is the chairman of UGC was making comment about a week ago. I read in newspaper saying that even undergraduate student can do research work. That should be the case. And also there is no barrier. A geography or history, a physics teacher, a physics student can also take up a biological studies. They can also do a biomedical research work. So allow them to do everything. So traditionally in 70s, a pharmaceutics teacher only teaches pharmaceutics, but not pharmacology. Pharmacology, same thing, vice versa, cannot teach chemistry. That used to be there in 70s. Nowadays, anybody can teach any subject, provided person has got some knowledge. That means many people do MPharm or PhD in some subject, and they do postdoctoral work in another subject, and they're employed in a different subject itself. So that happens depending upon their expertise, depending upon their experience in this one. Also their publication also. The publication matters a lot. If they publish in that area and they apply for a job, they will be selected to teach this one, even though basically they may be physics person, but he may be teaching pharmacology based upon what kind of work one has done it, and then orientation towards the particular area. That's why there is no water compartment between subjects. You should learn every subject. Keep in touch with the recent literature, and also attend meetings, seminars, workshops, participate in discussion group like this workshop. So most of the colleges nowadays, they arrange seminars, workshops, online teachings and everything. You should make use of it. You should attend those symposia, seminars and workshops, so that you can enhance what is new on what others are thinking about it. So you should be exposed to variety of environments. So the best research idea is the product of step-by-step development process. For that, understanding of creativity as a result of creative thinking, critical thinking, and logic are important for all research. These are required to generate new concepts, ideas in solving research problem. So basics is the creativity. We're all having creativity. So you must harness that one. The idea is the product of creativity and critical thinking. These two are very important. That should be this is what diagram you are given in the book. That is, it grows within your brain, that ideas. So everybody, all of us are endowed with, we're all endowed with two attributes, creativity and intelligence. Nobody is less, nobody is more. So everybody is having equal. Only thing, how much one progresses to the top level, that is more important. You have to be creatively thinking based upon your intelligence and how we can blossom. And that should be turned into innovation and implementation of an idea to work. And doing this one, again, review of it is necessary, and topic should be based upon that NIVIA. It should be novel, intentional, valuable, excellent, and appropriate. So that emanates from the strength here. See, creativity is the idea. That is, anything harsh environment, non-availability, that creates creativity. During 70s, 80s, not that many equipments were existing. When there was no ECG machine for every lab or polygraph study, we used to do the tissue bath experiments in 70s. But with that itself, many people have taken PhDs. Just the same thing happened with me also, with the 2 organ baths, with the tissue in vitro studies. I did the work with all receptor pharmacology work. At the time, receptor was in the infancy stage. Not like nowadays, you got a variety of receptors, starting from GPCR to the tyrosynchronous receptors, everything, thousands of receptors, but it was not earlier. That shows that people who are having very poor people, which you cannot afford their carom board, they on the ground itself, they created a carom board. Don't you think this is creativity? This is an example of creativity. So such creativity develops, and in cartoonists, for example, if you read newspaper, variety of cartoons comes. Those people are very creative people. Every day they create new cartoons. It is not that old cartoon, they cannot recycle it. So that gives a very good knowledge. Successful research requires several modes of thinking, not only one mode of thinking. Creative thinking, critical thinking, divergent thinking, and convergent thinking. Creative thinking is the force behind problem identification, often as an extrapolating exercise from an antecedent knowledge base, that is review of literature. It is one of the bases of choosing a research topic that involves moving between divergent to a convergent, and then setting up an idea from a selection of ideas, which I'll be showing with this one. That is, what is divergent? It is the ability to elaborate, think of diverse and original ideas and fluency in spirit. That is a brainstorming session, considering several possibilities. Again, when we come to the topic, I will cue that one, how several ideas may be there for every disease target. There will be multiple one, but you don't choose multiple things, you choose only one. How do you do it? Convergent. Convergent thinking narrows and refines from divergent to come to the convergent, refines the refinement, those divergent ideas, and finally settles only one idea. You can't work on multiple things. A investigator may be having dozens of people working in the laboratory, each one working on different targets, multiple targets. But a student, when it takes up one idea, second idea, third idea, but the investigator puts all the ideas together to interpret the disease model. So to settle one idea, one topic, research, critical thinking is important. You must critically think whether it is possible to pursue the particular idea or not. That is, see, this is how this is the one which you put the diagram in my book. That is the first page, first chapter in my previous book for research from ideation to publication one. See, this is the multiple ones. All these are the divergent one. From the divergent, we convert to 1. From 1000, we come to 100. From 100, we come to 10. 10, we come to 1. So, say cardiovascular. Cardiovascular is a very big area, even the number 1 killer disease, according to WHO statistics. But cardiovascular is a very big one. From cardiovascular, just you converge, you get 2, cardiac and vascular. Again, cardiac, if you take it, there is much more, various pathways. So you can get into only one pathway. So that way, it gets into only one point, that is the convergent pathway. Critical thinking is a refinement of the creative process accomplished by harnessing the creative aspect of problem identification and molding it into a tangible set of concepts from which hypotheses and objectives are generated, which is my second and third part discussing from the topic. Thus, critical thinking is convergent thinking, and a part of creative and analytical thinking. It is also judgmental, as it uses reason and logical choices before making it a final decision, and that helps in getting into this one. See, this is the various process of thinking which I put everything together. I know it's difficult to understand this slide, but based upon the previous discussion, which is the basis is intelligence and creativity, which helps you in developing ideas because it's based upon the creative thinking, and for that one we require a knowledge base and also keen an observation of what others are doing it. So from there, you pick up this one, refinement of ideas to work, and critically think through the problem, and then move from the multiple ideas to a single idea, and evaluate thinking, analytical thinking, logic. You get into a final decision of a research topic. One topic will be you'll be able to handle at a time. So the whole process based upon your attributes, what you have in your brain. So this, as I said earlier, we should have based upon the NIVIA, and we will be having a first year ideas or second year idea. First year ideas is very good one. This is what we wrote in the Nature discussion, the correspondence, that people should be involved in the first year ideas, not in the second tier ideas. In India, most of us are in this area, recycling the old work, which is not a good thing. We should always have a original idea, first year ideas. That carries a lot of commanding respect. You can publish in the Q1, which Dr. Balkumar will be discussing about that one, Q1 journal. So with a high impact factor like 4 and above, that impact factor journals, that happens only if you have a original research idea, not duplicate ideas. What most of us do is we refer back to several theses and then see what has not been done in that laboratory. Then we take another drug. But what has been done in other laboratories, we don't never look at it. That means review of literature. So 4, 5, 6 plants have not been done. So 6 plant work has not been done. So we'll do this one. That is nothing but a recycling. So that is very inappropriate. This is what most of the Indian laboratories are involved. That's why we are not able to produce a single original new molecule which can be a therapeutic one. So this there we lack. That's why always you people should concentrate on the first year ideas. And that, of course, whatever work, research work you do it, your guide will sign it off and you will get a degree, and thesis becomes a decorating piece in the library. Thousands of theses will be there one end to another end. When we visit a college, principals will take proudly says, sir, look here, hundreds of theses are here. We produce a lot of students here. But how many papers come out, they don't say. So that papers come out will depend upon the ideas of publication. Publication is very important to demonstrate that you have done a very good work. Otherwise, just putting thesis in line is, it doesn't carry any meaning. It keeps meaning means you produce so many people by number. That's all. That is the quantity, not the quality. India now occupies the 3rd or 4th position in publication. Earlier it was not. So first comes US, then European countries. China occupies 2nd or 3rd position, competing between 2nd and 3rd, and we are the 4th in producing number of papers. Quality wise, we have got, because quantity wise, we are occupying 4th position in the world. Lots of papers are being published. During COVID time, hundreds of papers published from northern India part, not from South India. Reason is lot of research being done in the northern India, but South India, I could see 2, 3 papers came. Only from here and there, bits and bits. Nothing, zero from Kerala. This is what last week I was in Cochin. I was talking to the principal. I said, yes, sir, we don't do research. We come at 10 o'clock, go at 3 o'clock. What research can be done? Only ours is a teaching institution, but research, you must do it. Our management says you must do research, but somehow we are not into that gearing. So that COVID papers, anything published, they would have accepted at that time. During 2020, 21, thousands of papers came from Chinese. They occupied number one. Of course, they are the one who created one, and they're able to publish both non-clinical and clinical. And some people citation went up so high. Some people had about 10,000 citations for one paper within about 2 years. That way, and in northern India, small Jhansi Rani Lakshmibai Pharmacy College, Meerut College of Pharmacy, and such a small colleges, they publish papers. Of course, not original one, they're all review articles. Any aspects they publish it. But such trend is not there in southern part. I don't know what is the reason. That's why I told you this whole workshop, some of you can take a lead. Those who are good in writing, they should publish it in the plagiarized journals. Again, publication should not be in a plagiarized predatory journals, which I'll be talking in my next lecture. That is the first, second, third, fourth lecture. If you're able to think, you will never be out of ideas. Thinking helps you come up with new ideas. This is what I said. Critically, you should think and have a creative thinking. The ability to think creatively breeds confidence, which builds character strength. Producing original and honest work will not only reinforce students' critical thinking skills, but also reflect well on the institutions that have worked hard to strengthen the overall institutions, managements, or the government spend crores of rupees and we must make use of it. Learning infrastructure and maintain the reputation. Ideas should never be plagiarized into a second or third tier ideas. Should always remain as a first tier ideas. So this is what again I'm summarizing, so that you should not lose the track what I've been telling for the past 15-20 minutes. Again, intelligence, creativity, these are the two attributes every individual had. This one, that is intelligence, creativity, and you have to have input from your mentor, review of literature, creatively think, imagination, and idea detection, getting divergent to convergent, applying logical, critical, analytical thinking with a brilliant ideas, get into research topic, research question, hypothesis, objectives, designs methods, physiology of work, data collection, thesis publication, successful career. So this research cycle continues for the investigator. Every time they have to go through the cycle to get more and more grants, more and more money. So students will be going only one time, and then if they become again investigator, they'll get into this pathway. So this continues indefinitely. So the rest of the story, what you need: intelligence, creativity, thinking, motivation, skill, good environment, laboratory, the library, everything, perseverance, learning strategies, perspiration lead to success. What you require is 3 P's. One is the perseverance, perspiration, and you should persist. Persistence to do work. Yes, I persisted in my work to produce a thesis work, produce a paper. That should be there. So the project of a thesis or should be written in the ink of creativity, intelligence, and hard work. Anything requires a perspiration. Hard work is very much essential. So you then only can persist in your work. Aggressively must advance your knowledge. See, always write protocol. Don't write protocol after you submit thesis, or because it is required by the university before producing a thesis, you must have protocol. People start writing protocol. This used to be there in 70s, 80s, but no longer. Now protocol is a must. Then only you produce a thesis. So again, I'm giving the scheme. So once again, to reinforce that where I am now, research topic. This is what I was telling you previously. Divergent ideas. Say, for example, a person wants to do a neurodegenerative diseases, dementia, or Alzheimer's disease. There is not only one target. There are about 2-3 dozen targets are there. I just listed 11, 13 because of not to run out of space. See, you may be in one of these things here. You may think, depending upon your laboratory equipment, how much you are equipped. What about your guides expertise in which area? You may take any one of them as your target for pursuing to this dementia work. Because I went through a lot of thesis protocols and heard a lot of students protocols presentations. A lot of people work on Alzheimer's disease because maybe it's easy to work or what, I don't know. One of the reasons is a lot of these are being produced in this area, and they choose. Sometimes they say, oh, this is very number 8, acetylcholine esterase inhibition to increase the levels of acetylcholine. That may be the root cause of Alzheimer's disease or dementia. So they go for 8. Somebody say, no, I work on this one. The increase in the expression of monoamine and neurotransmitter dopamine. So you may choose one of the things. That's why all these things are the divergent one. Now you will converge into one of the targets. But the top protein, should I do it or not? See, this is the how. Same thing with hypertension, for example. There are a lot of targets how the blood pressure increases, but you take only one target. Again, within the target, again sub targets will be there. So that's the way how you proceed to with the narrowing down to the topics. So topic is best formulated into a question. Good research must begin with a good research question. It should be a thought-provoking question. The question is the starting point, sets the framework, and it will guide the rest of the study design. So it's important to get it right. The research question is then expressed into hypothesis. From the research hypothesis, you get into objectives. So I'll be giving examples for the research questions, hypothesis, and objectives in subsequent slides. So here, a good research question should pass the final test. Should be feasible, interesting, novel, ethical, and relevant. I'm giving examples. 3 examples I'll give. Same example I'll repeat for the hypothesis, as well as same question, same topic one I'll repeat for the objectives one. So carefully follow this one. I will never change this one. So in that way, you will be able to understand that how I can. But always you should read this title. If you read title very carefully, that's why whenever some students give presentations, I sit through a lot of presentations. So I tell them, stay here for 1 minute. Let me dissect out your thesis topic. So hepatoprotective. So it should flash your mind. That means they want to work on something on protecting the liver. And what antioxidant effect of what, which here? Oh, gallic acid. So they're working on a gallic acid, and its mechanism could be antioxidant effects, where it's able to have a protection at the liver. Why protection? Because they're damaging the liver here. And how they're damaging the liver? By excessive doses of paracetamol. In which species? Mice. So you got all these things. Now we can immediately think about it. What are the students? This is a protocol. Once you analyze every word, you should analyze it and the topic. Then you can say, oh, this should be this question, this is hypothesis, I got all the things. So before student presents it, when I read this one, I've already formed in my mind what could be the next, all those 3, 4 comes. So anywhere student tumbles, Emil will say that, go back to your topic and read it carefully. This is what should have been there here. So that's why that title always should be able to explain properly. That means you must give a very good title. It should be descriptive enough so that people can understand what follows next one. Don't shorten that one. Of course, there is a 40 characters limit is there in the publication work. In the publication, they say not exceeding 60 or 70 characters for the title. Now, I will put a question here. How is paracetamol metabolized in the body? Does it involve 450 enzyme? And what could be the product that causes damage here? How does paracetamol cause liver injury? Mechanism comes here. What are the mechanisms by which drugs can elevate liver damage? Mechanism which drugs can elevate? Here only one drug is selling. What other drugs can be doing? Gallic acid is one. What biochemical parameters indicate liver injury? Antioxidant effect, one as it gives. Any other parameters which you can think about it, where it causes liver, like for example, increase in the AST, ALT, AP, enzyme levels may increase. That could be the biomarker. So then you may think about that biomarkers here. What are the endogenous inflammatory molecules that involve hepatotoxicity? What is the inflammatory molecules? Is the TNF alpha is involved, or what are interleukins are involved here? Does oxidative stress reduction of the antioxidant effect shield against the liver damage? Antioxidant effects is one of the mechanisms. We cannot discuss all the mechanisms. Student may not be able to work. So one of the mechanisms they taken it. So in this way, you get all the research questions. Then you will go back to the next one. Then you can answer it. What could be my hypothesis? What could be my objectives for this particular topic? See the second one. I continue further one, the mechanic, giving all the mechanisms here. Second topic, you see this one. Nano-formulated ellagic acid ameliorates. Remember word here. Nano-formulated, not the simple ellagic acid. That means you must be having two. One is the plain ellagic acid, another must be nano-formulated, because you have to compare these two things. Otherwise, you cannot say that, oh, nano-formulated is far better than what? Regular normal ellagic acid. So it means there should be two samples here. So nano-formulated versus normal ellagic acid ameliorates, which is pentylene tetrazole, PTZ, induced experimental epileptic seizures by modulating oxidative stress. So they are inducing convulsions chemically, not electric shock, by giving PTZ, and modulating. What mechanism should be there here? One is oxidative stress, other is the inflammatory cytokines, maybe interleukin 6, interleukin 1 beta, and are also TNF alpha. So that are the inflammatory cytokines, and apoptosis in the brains of male mice. So you got, this is the one which I copied from the publication one. See, this is a very good title, which gives everything here. Now, based upon this one, I developed this question. Is ellagic acid that has been nano-formulated better and more efficient than ellagic acid in terms of dose, duration, and PK? So dose means possibly they will be having a 2 times less dose for the nano-formulation versus ellagic acid. That definitely should be. Otherwise, what is the fun in having a nano-formulation if it doesn't improve the delivery? What kind of studies demonstrate the neuroprotective effects of ellagic acid? And how are the anti-conversion properties of nano-formulated ellagic acid and ellagic acid investigated in mice? What distinguishes them? What parameters can distinguish? What biochemical parameters correlate with the anti-conversion effects of ellagic acid? What kinds of inflammatory cytokines So would you like to estimate any cytokines here? This should be transformed to the objective one. Yes, if you think that inflammatory cytokines are involved, then you can have an objective. Oh, I will be estimating TNF alpha here or interleukin 1 or 6. So you should come into this one. And regulating proteins are involved in the oxidative stress and apoptosis. So these are the questions we should ask. Now go for third one. This is very much popular with the students. I copied from one of the students the protocol, this title. And and then student wants to make a nano formulation also of this extract in scopolamine induced. How that cause neurodegeneration and get into Alzheimer like activity by injecting scopolamine. So you got all of them here. See, if you dissect all the things here, now how does Alzheimer disease differ from dementia? You should ask the question, which one I'm proceeding here? What are the various underlying factors contributing to development of Alzheimer disease? Genetic factors, you understand all the factors. What are the signs and symptoms? What are the hallmark features of AD? What is the anatomic pathology of AD? That means you have to take out the brain and go for imaging. Which biomarkers has validity for Alzheimer? So these are the 6 questions I developed from this for students did not write it. Then I told them, yes, sir, I actually included these questions because they did not think about it, including these questions, which a person with a layman who doesn't work on CNS, I was able to come up with these 6 questions. The students miss these questions. So this is very easy to do it if you have got a little bit background knowledge. Understanding question is often answer. So now you understood the questions, ask the questions, you understand. Now you can design the study. If you design the study, it completes the answer. Now coming to hypothesis. Now research question. Next step is hypothesis. Yes, it is a central component of the research process. Research questions and hypotheses serve as guides to the study, explaining its purpose and guiding its direction. The research question should be translated or reframed into a workable, testable hypothesis to give a tentative answer. That means the question becomes a statement. The previous question becomes statement here. It predicts in advance the outcome of your study. Only prediction, not proving. Hypothesis is not proving. Statistics is not proving. In this case, you predict, yes, this compound may work. Yes, this compound works. So then you say statistically, you have shown that P is equal to 0.05, less than 0.05. Yes, it works. A hypothesis is a specific statement. It's only a statement of a predicted relationship between 2 variables. A dependent variable, for example, what is the dependent variable? Blood pressure increasing or decreasing, atherosclerosis, cholesterol 1. And is an independent variable because you are giving either a diet induced or you're giving some drug to manipulate that increase or decrease intervention. That is the independent variable which you can control. Whereas dependent variable you cannot control because it depends upon the particular model. So a relationship between the dependent independent variable, if you use these two, the statistics is necessary. Again, coming back to same example, no change. Hepatoprotective and antioxidant effects of gallic acid. So you are predicting, yes, there is a response to gallic acid. Then you say, yes, the gallic acid treatment alleviates the progression of inflammation in paracetamol-induced hepatotoxicity. With that hypothesis, you proceed. Or you can also say antioxidant, because you use the word antioxidant here. Antioxidant effect of gallic acid relieves the progression of the inflammatory mediator TNF alpha in, that means you are estimating TNF alpha, it shows that one. And this should be able to decrease the TNF alpha, which increases by giving paracetamol. And that's why you say antioxidant effect. And then it means you will be estimating a lot of antioxidants, this oxidative pathways in your work. This gives a clue for what are the objectives you can coin. See, everything is once joined together. Second example, nanoformulatic acid ameliorates pentylene tetrazole induced experimental conversions. For example, here cytokines. Hypothesis. It is hypothesized. You can also use the word like this way. See, various ways of writing the hypothesis. It is hypothesized in our study that ellagic acid has anti-convergent activity because you are using this model to study this one. Is to say yes, anti-convergent. If it doesn't have, you can say it does not have. Null hypothesis, alternative hypothesis. And it may modulate Caesar substitute animal model. Or you can say nanoformulated allergic acid is more efficacious in elevated experimental seizures than, when you use the word more and then you have to prove it by statistically. Whenever you use the word better than or the inferior then you require a statistical model to show that yes, one is superior to that of the other one. Third one, anti-Alzheimer activity of the leaf extract, and this one is having a anti-Alzheimer activity. Hypothesis: Polyanthus tuberosa and its nanoformulation both inhibit Alzheimer disease in scopolamine-induced male rats, or you can also say leaf extracts from Polyanthus and its nanoformulation counteract Alzheimer's, dementia, and neurodegeneration in male visitor rats induced by scopolamine. If you use all of parameters in the scale, otherwise restrict to one of them in case if you are not determining all of these symptoms. Now, for example, this one I copied from one of this was a very beautiful review article from Indian authors from northern India. They put up this one. Published one. See, they showed pathophysiology and pathophysiological hypothesis of Alzheimer's disease, various targets. Is hypothesis necessary? All biological research, which we all of us do it, biological research, including discovery science, is hypothesis driven. However, there is exception for all cases. All studies need not be conducted with hypothesis. Descriptive studies, for example, describing characteristics of a plant, like pure pharmacology work, or a chemical compound synthesis, you do it. You don't require hypothesis that how you do the synthesis. If you do only synthesis part, but after synthesis compound, if you test for its pharmacological activity, then you require hypothesis. If you just synthesize a compound, you don't need it. Only one variable will be there.
Hello. Let's break for 10 minutes, have tea and come back. Right? Please, first row ఇది ఒకటి చూసుకోండి. జాగ్రత్త. Camera check.
Hello.